Hi, my name is Alexandre Bencz. I'm a tech lead here at Motu. In this presentation I will show how Motu is using Dapper to solve the main problems here that we have. First I will talk about what is a Motu to help all of us understand what is a Motu. A Motu is a bike rental. It's a startup here in Brazil. We started in 2020, just renting bike. That's the main service of Motu. After some months we saw that all the delivery boys have a big problem here, that they don't have any job. So we create a delivery system to help all these delivery boys have some work, some job, to make some money. We started with the idea to serve the unserved, so we created a completely cheap rental, a delivery system that's not necessary to long time waiting for some approval. So the delivery boy just rents the bike and they have access to delivery system. With this we have a assembly line system. We are building motorcycles. We have a total support every day, every night. We have some monthly maintenance. We have the biggest mechanical space here in the South America. We are going to another countries like Mexico and Colombia. We in the process to be some of the Brazilian unicorns in startup. The main idea here is to show how we use a Dapper to resolve some big problems that we have. Like we have two big monoliths here, the Motu backend and the delivery system backend. When we found Dapper, we are looking for some actor systems. We saw Aka, Proto-Actor, and Orleans too. But when we saw Dapper, we found everything that we needed in a single system. PubSub, data abstraction, actors, and a lot of import stuff to create a microservice. And the best of one, it helps a lot to just strip the monolith in single microservice. We have a quite long process to choose the Dapper. First of all, why we need Dapper? When we saw Dapper for the first time, we take some months in learning, discovering, testing, and make a lot of stuff like compare with another actor systems. The actor is the main process that we need here, because we have a lot of separate processes that are high concurrent, like the order, delivery boy, and the registration steps in the user management and so on. So we start testing it on version 1.6.3, if I remember correctly. The first thing that is most interesting part, the smooth learning curve. So just get the SDK and test it and put it in production. It's quite easy, quite fast compared with Aka. For example, Aka we have to configure a lot of stuff just to making a single cluster. With Dapper we don't need to make all this configuration, and with Proto-Actor is the same. Okay, so we start to migrate the order management system that was in version 2. We start to migrate it. This project has a biggest problem, a really big problem. That was a single monolith with a lot of data in memory, not in cache like Redis or another database. And this project has a biggest problem, not only about all the data in memory, but it's not possible to scale it. So to scale it, we need to put more memory, more CPU in the server, and we are completely locked in a high concurrent process. For example, a delivery boy accepts an order. Okay, since all this data is in memory, we need to handle all the concurrency inside and over this object class. So we build some stuff inside the order management system, like an actor, but not so good like an actor. So we start migrating this process of order and delivery man system. We created a delivery boys controller, a order management controller, and we start to migrate all the other systems that inside this order management system. Not only the order controller, delivery controller, but we create gateways, kick system, and order sorting system, other stuffs like this. You can see in this slide we have a signal R system that makes a bi-directional communication with the app. We also need to migrate this because we don't change the protocol between the controller and the app. So we have a really short time to migrate this system. We got just a single month, and we did this migration in just a single month. Some days more, but we migrated more than 100 lines of code in one month using Dapr. We made some estimation that if we are using the AK, we are still building this coding. One of the biggest reasons that we migrated this, we see the necessity to migrate this project, and not only this project but other projects, is the complex to maintain this service. With Dapr, we solved all this complex because we don't need to worry about threads and high concurrence process over the object. So after the migration, we have a complete scalable system, easy to maintain, a better management over all the data. We have the benefits of pub-sub system that we don't have, so we create a complete event-based flows. So we just publish in a queue that order is accepted, for example, and all over the system get this information and do some process. This decoupling helped us in create a more scalable system. As now, just for having some idea, we have 44 microservices running in production using Dapr, and I don't know exactly, but I think that we have more in the other process here in the Motu, like the user management. Now you can see here we have a complete decoupling system. We saw some problems with Dapr that we solved quite fast. It's just mistakes that we made here. For example, with the actor reminders, we have used it in the wrong way. All the Dapr community helped us quite fast in resolve this problem. And solving this, we got a complete stable system. And we have some services that are running more than 20 days without any restart. So we saw that Dapr is completely stable for us, give a really big help here for us. With Dapr we get interesting stuff. It makes the development really more fast. Like I said, with another actor system like Yaka, we got a lot of time in just learning it or trying to put some cluster online. And all the key management and the service discovery system makes the development really more fast. Just know how to configure the app ID, and well, it's quite easy. Development goes really fast. To help us in making a more fast development, we create a building blocks that encapsulates all that service access process. We have a single DLL with encapsulate all the service access. So we can just call the service access to get access to another service. The service that are making this call is they not need to know the API ID, if the service is a gRPC or HTTP. It's all encapsulated. So this makes the process more fast. It's quite good. And all the abstractions that Dapper give for us in terms of queues. So, okay, let's use, for example, RabbitMQ, Redis, or Kafka. Give us a really more security about the coding process, okay? Because we don't need to worry about the hardware and the peripheral systems, and need to configure, write some code for just for RabbitMQ or Kafka or Redis. You can just change the plugin, and well, it's working. We did this sometimes here. We got some problems, for example, with Postgres and Mongo. We tried with Mongo, we got some problems. We just changed the state store to Postgres again, and it all works perfectly. This gives us an easy way to handle all the codes. So it's a wonderful system. It's all what I have to say. We have about the system stability and the speed. So we have a lot of services running in production in Kubernetes. Some services running for more than 11 days. I think that we have some services in another process of here in Motu that are running on more days. We have some services running some just for 11 days because we released some upgrades. But the best part is zero restarts, and the Dapper shows how stable it is. We have here some samples of the execution time. We have, for example, here the accept order. I put here the screenshot showing the time in the roll process. Okay, the roll process to accept an order. This process involves calling 2 actors and publishing 2 queues. So we got just 0.05 seconds. It's quite fast for the roll process of accept an order, or collect an order, or deliver an order. And all this process involves make changes in state store, and all the state store that we are using are PG Postgres. So we are changing some data on the database, publishing, calling actors, and all is running really fast. Even when we have some high workloads, the process is really fast. And the future shines for Motu and Dapper. We are creating more and more services running with Dapper. We have a lot of integrations with delivery and the rental process that are born with Dapper, and all integrated with Dapper. We have some services that we are just accompanying the Dapper with it, like the marketplace management, and we are building a fintech and an insurtech that also are born with Dapper. So we are using it a lot, and we are going to continue using it. Thank you. That's it.